Alright, here's the birch tar and gum base mix out of the refrigerator. It's also the air is cooled down to about 88 degrees. I just saw the temperature. Okay, let's see if this will break. Yep, it snapped pretty easily actually. It did bend a little bit. It's still a little bit flexible. Yeah, it doesn't snap completely cleanly. That first one did, but I guess it's warming up quick. There we go. So this will snap in cold weather too, but not as easily as the asphaltum. Okay. You'll just have to take my word for it. Yeah, it doesn't snap as easily as the asphaltum. It still has a slight bit of flexibility to it before it snaps. Okay. So the important thing to take away from that is to realize that temperature affects the glues, affects these natural glues. So in my future discussions, I'm going to be looking at other materials for cold weather glues. And one of my ideas, I think, I'm going to experiment with clay and oil mixes, like modeling clay. If you've ever worked with that, it gets really hard when it's cold, but it doesn't break. Alright, I'm going to see how that works as one example, and try some other cold weather types of materials. Okay. And in a perfect world, I'd make samples the same size, like little cylinders of every type of glue, write down the temperature, and then test all of them to see at what kind of stress will break all these little cylinders. Something I did in college in engineering labs. But I don't have the time to do that now. Maybe in the near future, hopefully. Okay. One more note on this. You can see there's a lot of bubbles in this mix, and this has only been heated for about 2 hours. Okay. I need to heat this and warm this up for another maybe 6 to 8 hours and let it bubble until it settles down a little bit, so you only get little tiny bubbles in it. For me, this is typical of what happens when I use powdered asphaltum. I buy it in a powdered form, and when I melt it down, it tends to bubble a lot. Okay, and it has to simmer for a while before the bubbles get really small. Right now, they're really big. Just in case you're wondering what that was, I get that a lot with asphaltum. All right, so this needs to be heated to a liquefied form for another 6 to 8 hours. The last batch I heated was like 12 hours before it settled down, so maybe this one needs a little more than that, but we'll see. Just a side note before I forget. Okay. Now it's 88 degrees, and it's a lot less sticky. The birch tar is a lot less sticky. In fact, it's just barely. If I keep my finger on it, it warms it up and gets it more sticky, but if I just casually touch it, it's not very sticky at all. So it would be okay, I would think, in cool climates in a quiver with arrows side by side with the fletching of other arrows touching this glue. I think we're pretty safe. But when it gets to be a warm weather situation and all these are stuck in the quiver and all the fletchings are touching the shaftments and all this other glue, I would imagine it would become a very sticky mess. So this type of glue is used in cool weather but not cold weather. Although on the fletching, I don't think it matters. On the arrowheads, I do think it matters. It won't really matter if this becomes brittle on the fletching side, but it does matter on the tip side. And there's one more thing about the old world arrows. Let's use arrows in particular that I want to kind of make a note of. These are close-ups of two of the arrows in the quiver that was found near Utsi. Okay, and they both have chert or flint tips. And this is birch tar. They determined this was birch tar. Okay. Now there's an interesting thing here about all of this. There's another close-up. Two interesting things here. If you notice, this feather is in line with the knock. Okay, this fletching here. That's one interesting thing. Then the other interesting thing about these is the glue is actually not used to glue in the arrowhead. It is over the top of the wrapping, kind of like a waterproofing layer over the top of the wrapping. I don't think there's glue actually in the arrow, between the arrowhead and the wood inside. I think all this birch tar is on the outside, which is a very important point, I think. Another close-up of the arrowheads with the glue. Okay. This one here is broken. They both broke off in the quiver when discovered. Both these arrowheads were broken, and this was just kind of I guess barely put back into place, and this was shoved all the way back in. This is in here pretty deep. Okay, this one is not. This one is just about that deep. Has a small tang on it, and this glue has spread out. So because this is actually a stemmed point, it's not a isosceles triangle. This is excess glue and wrapping on both sides and makes it look like it's an isosceles triangle, when actually this arrowhead, when they x-rayed it, is a stemmed arrowhead. Okay, this one is a stemmed arrowhead too. All right, and the glue is on the outside, which I think is an important distinction between the European and Native American ways of hafting. Right. The birch tar is actually used over the wrapping, maybe some under the wrapping too, but I think primarily it was used as a waterproofing agent, as well as a glue. I'm sure there are examples of birch tar inside the joints. I know that there were some inside the axe joint, Utsi's axe, so I know that it exists. But on the arrows and on the arrowheads, it's important to note that this, at least some of this glue was used as a waterproofing or a covering over the top of the binding, and it would probably only be used in cool weather, because when you have these together in a quiver and they've got glue over the binding, they'll stick together if they get sticky. Okay, so it has to be cool enough so they won't stick together in the quiver, but yet not so cold that this stuff will crack and flake off. Okay. Now with Native American arrows, you don't see very much of that as far as glue on the outside of the wrappings. Here's some arrowheads, mainly from California. Some of them are Eskimo. Okay. And hopefully we can see the close-ups here on how they're wrapped. They're usually just two hold downs. See if I can get this to focus. All right. I'm gonna kind of go slow here. If I can find my pencil. All right. Hopefully that's in focus. There's two hold downs here, two hold downs there, two hold downs there. And the tip of the foreshaft does not extend past the notches or even get close. All right, this one's very low, down this area. So you can see what I mean about just 2 hold downs on. These are various different types of arrowheads, but they're hafted in basically the same way. Now these here are, these 2 on the outside are elk antler, it says in the description. The middle one is bone. These are from Northern California on the outsides, and this one is a Sioux Indian bone arrowhead. I suppose this has a stem of some sort in here. But these I don't think they are stemmed. Well, this one might be. This one probably has a stem inside. But the curious thing about this one here is there are no wrappings going into the notches. They look ornamental. The notches look ornamental. All the wrapping appears to be down here. There's probably a stem, a long stem in there. This one does not look like it has a stem, but just wrapped between the notches and with glue in there, and maybe paint has oozed up onto the blade a little bit. And these are 2 slate arrowheads, serrated, and these are also hafted with 2 hold downs. Okay, and they're actually quite wide for this foreshaft. And I imagine that there is a stem in here too on these, because I can't imagine it not be stemmed with such a little bit of foreshaft extending into the body of the arrowhead. They probably do have stems also. Okay, so that's why I say, and also on other pictures, that most of the time you'll see just 2 hold downs for the hafting on various configurations. Okay, whether it be narrow with notches high up, or wide with notches down low. Okay, these look like they're eared and notched. Alright, so with the large variation, they're still hafted in the same way. That was my point there. And there's no real glue over the wrapping, but they did use paint over the wrapping, so maybe paint was more common in the New World as opposed to the Old World. Okay, on top of the wrappings. In the Old World, it would appear that the glue was applied over the wrappings, and at least in some cases, between the wood and the stone in the joint. Okay. Another thing I want to bring up here is this type of arrowhead here. With a wide stem arrowhead, you can extend or widen out the shaft, or I should say, this is the fat end. It's just been shaved down to leave this fat to accept a very wide arrowhead. Okay, and I'll get into why, how I think this might carry over to other designs too, not just this particular one. This might be an oddball, but I think that some of the other arrowheads were also hafted in this way, that I'll be showing here in a minute. Okay, with the very wide tip of the arrow. Now these are 32 inches long, which is pretty long, and they are Algonquin split hickory. Okay, and there's various forms, and I don't know if these were just made for display. I have a feeling that they are actual working arrows. Okay, I'm going to assume that they're working arrows, so this will be part of my discussion, this type of situation, when I discuss some of the other hafting methods coming up here. Okay. One of the controversial things that I wanted maybe add a little more to today is the Basel Notch. So let me do that here. Now on some of the Cahokia points, The basal notches are very deep, but some of them are not so deep. Okay, some of them are just minimal. Some of them are very deep. And I think that depended a lot on the skill of the flint knapper. Okay, some of these were made out of exotic materials. They may never have been used for actual arrows, but I'm going to assume that they were. Okay, and in the comments on one of the videos, I got an explanation for the notch that I've heard before. Some people think that, and I'm not going to discredit this explanation, but some people think that the notch was to help in gluing the arrowhead to the shaft. Okay, the more glue in there, the better. In other words, okay. If you didn't have a notch, you wouldn't have as much surface area, and you wouldn't have as much glue in the joint. Is basically the gist of it. So that's another explanation. I don't want to leave any explanations out. I know I have my own biases, but I don't want to leave any explanations out because it's better to have more explanations than fewer, I think. And some of you can also come up with other ones. There's also this. I wish it would focus. I really wish it would focus. Yeah. I was thinking of this the other day. Some of these, when you look inside the shaft or foreshaft, it has a pith. Now I'm wondering, since they knew it had a pith, they would make the width of the notch the same width as the pith, because they know that the arrowhead needs to sit on wood anyway. So why have stone here in the middle when there's nothing really to support it there? I mean, that might be a possibility. Let's see what else. On things like this, on these shallow notches with strong corners, I can see where it would be of benefit to have to make a solid wood foreshaft with no pith and have a slight rise in the middle. Okay, you can't do the slight rise in the middle if it's not solid. Okay, because the pith will take away that point in the middle. There won't be really anything to support a point in the middle. You know what I mean? It has to be split from a piece of wood and then carved down with no pith in the middle, and then sawed in such a way to leave a V notch. Okay, that, and then matched with a strong basal notch in here could prevent sliding around in the notch of the foreshaft. Okay. So that's a possibility, but it's a lot of work. You have to split out a solid piece of wood, and then you have to think about which way the grain is going to make sure that you cut into this foreshaft, not going with the grain but against the grain, and then make a little peak in the middle to match the notch in the base. And if this notch is not on center, you just have to live with it. It could be off a little bit, and it's hard to get this perfect and then that perfect, and you stick it in there and it's off. Then you have to take it back out and you have to saw it. Maybe this little peak ends up way over here somewhere, and then you put it back on and then try to center it. This peak may not end up being in the middle, so it's a lot of work. You have to be very precise, and there's a lot of things that could go wrong with it. So if I were doing that, I wouldn't bother. I wouldn't bother with this technique, but I can see that there would be an option. Okay. I suppose it would have been done that way. But for me, I just think that this notch is not something that has a very complex explanation. I think that the reason why they were put in is going to be a simple reason. Okay. All right, enough of that. Let's see, what else? There was some other questions I got on some arrowheads that are unusual. Like arrowheads like this that are more or less equilateral triangles and very thick. Okay, how do you haft these? Well, the way I would do these is with a foreshaft, either with an expanded end, like we saw in the picture, purposely expanded, or just let the foreshaft naturally taper. Put the skinny end down here and the fat end up here. And then put a couple of hold downs. Somewhere on here. Okay. Either purposely shave these down, leaving it bulbous at the tip of the foreshaft, or the arrow shaft. These don't have to be foreshafted, but in the majority of cases I think they were foreshafted. Okay. So that's how I would haft these, with thick cross sections and kind of odd shape. Most arrowheads are not equilateral triangles, they're more isosceles, twice as long as they are wide. Okay, but there's a lot of these in the archaeological record, so that's how I would haft those. Now, as far as these hold downs go, the physics involved will tell you that the higher up the notch that you use for the hold down, gosh, I'm being kind of sloppy tonight. The higher the angle here, the better it holds it in. You know what I mean? Okay. I don't know if you know what I mean. This will stay tight when you pull on the arrowhead, okay, because it's almost vertical. If you've got the hold down almost horizontal, this has a tendency to this will swerve. Okay, there's some room. If you pull it out like this, this hold down is not really resisting this movement going this way. You'll be able to pivot that from this point here. That will pivot like this, so it doesn't really hold it in very well. What this does on these low notch hold downs, I think, is just keep the arrowhead from doing this instead of pulling out. Okay, this is more to help the arrowhead not pull out, but it will rock back and forth easily. Okay, this one won't rock back and forth as easily, but it will pull out more easily. So there is a consideration, or something to think about in the different strategies on how to put in these hold downs. Okay, is it more important for you to stop this movement or stop this movement? Okay. Like this might be an arrowhead type that's placed in a quiver. So when you withdraw the arrows quickly, these arrowheads are not going to pull out. But these types of arrows or arrowheads might be held in the hand. These type of arrows held in the hand. There's no quiver to pull it out from, so you don't have to worry too much about it being pulled out. You know what I mean? Okay, so we're approaching 25 minutes. I don't want to take too much longer on this. Let's see what else. I hope that explanation was okay on these hold downs. I think that's it for this. Those slate arrowheads that we saw in the book, I think they were stemmed. You know, it has stems on them. This is kind of a crude representation, but you get the idea. And the hold downs were, you know, kind of flying out here. They didn't care too much about, you know, they're not worried about these hold downs kind of flying in the air here. They were just concerned about preventing it from slipping out, I guess. I guess it had a contracting stem that's easily pulled out. Okay. All right. Let's see. Okay, that's it for this one.